All right. Now, this is another segment of videos that I want to make for those persons that are writing the UTME or SSC 2026 examination. Now, the examination is very, very tricky, but there are some videos, of course, that I've lined up for those persons that are preparing. But if you want to prepare for an exam like the UTME exam or the SSC exam, most mistakes that persons do make is that they fail to look at the foundation, the nitty-gritty. You don't just jump into the subject matter. So for this series of lecture, I will be looking at, of course, some points, basic point. Now we used to do it without wasting much time. Videos usually very short, so that you're able to grab the major point. Then, of course, now look at the segment of the questions, and most questions I'll be taking will be coming from, of course, the effective compendium authored by me. Now, this book is basically made of points and, of course, questions from different exam bodies they've asked over the years, and likely questions that you need to know. So we are going to be revealing these questions. So if it's your first time of watching this video, do well to subscribe and, of course, share the video. Now quickly, let's jump into the matter. Now I just want to bring out some nitty-gritty, some important areas that you need to know. Now, talking about atomic chemistry, first off, you need to know definitely as a chemistry student that, of course, that atom is made of the nucleus, which is at the center, with electrons, of course, revolving round, just like it was stated by Nibor. But remember, you need to put at the back of your mind again that there were different scientists that postulated or observed, or yes, observed the structure of atom. Now I want to list the four major scientists that described atoms. Now the first person that did describe atom was who? Was John Dalton. Now what did John Dalton say as regards atom? John Dalton said an atom is indivisible kind of particle. No wonder John Dalton's model is what is now regarded as the billiard ball model. So if they ask us in the examination, they said, who described the billiard ball model of an atom? Of course, the scientist that did that is who? Is John Dalton. Now, the second person that tend to observe atom and describe an atom was Sir J.J. Thomson. Sir J.J. Thomson. Now, John J. Thomson said an atom is a sphere of positively charged particles in which negatively charged particles are what are embedded. Now, this John J.J. Thomson's model is what is regarded as the what? As the plum pudding model. Now, you must put this at the back of your mind. Now, these are things of the foundation in chemistry that you must know so that you don't begin to cram chemistry. Now, look at it. The third person was actually a student of who? Of J.J. Thomson. And who was that? That was Lord Rutherford, which is also known as what? As Ernest Rutherford. Now, Ernest Rutherford actually brought about the planetary model of an atom, where he described that an atom is made of a center. That's why if they ask us who discovered the nucleus of an atom, of course, is Ernest Rutherford, and he did that through an experiment which is known as the alpha scattering experiment. So if they asked us, or if you are being asked, who described the alpha scattering experiment, or rather the alpha scattering experiment was proposed by who, or rather was done by who? Was done by Ernest Rutherford. But this Ernest Rutherford's model is what is regarded as the what? As the planetary what? Model. So if they say who described the planetary model of an atom, obviously is Ernest Rutherford. Then a student of Ernest Rutherford. Remember, Ernest Rutherford was a student of J.J. Thomson. Now, a student of Ernest Rutherford now proposed that the planetary model was quite correct, because he said that an atom is made of a center with electron revolving what round. But he now objected. Who was that? That scientist is what is regarded. His name is what? As Nibor, that brought about the what? The quantum what? Model of what? Of an atom, where it actually said that the electrons are actually going around the nucleus, but in discrete orbitals, in separate orbitals, that the electrons can move from a lower energy level to higher energy, or higher to a lower energy level, but can barely fall to the what? To the nucleus, though they do fall to the nucleus in a process known as what? Known as K capture. So this is the model as proposed by what? By the different what? Scientists. John Dalton said it's like a billiard ball is indivisible, but meanwhile, we should all know that atoms are quite divisible, and of course they are made of what? Protons, electrons, and what? And neutrons. But These are not the smallest particle of an atom, though in other lectures we'll be looking at it. And there are smaller particles which are known as what, quarks. But these are the small particles that subunits that are made of, that are found in what, atoms. So as an SSC or UTME student, if you are being asked how many subparticles do atom have, of course 3: protons, electrons, and of course neutrons. Now there's one area I want us to focus on today, then we want to look at questions on them. Now these electrons are not found in the nucleus. Obviously that the nucleus is made of what? The nucleus is made of 2 atomic particles, which are the protons and the what, and the neutrons. Electrons are revolving around in orbits. No wonder if they ask us where are electrons found in an atom, they are found in where? In orbitals. Very good, in orbitals. Now pay attention to this point. Remember that we are just looking at the points before we begin to look at questions, but these are basic areas that you must look at. But let's look at it step by step, more, not rush. Now look at it. Now you have known that the nucleus is made of protons and neutrons, yes, and of course that electrons are found in orbitals. So where are protons and neutrons found? They are found in the nucleus, but the electrons are not found in the nucleus. They are going around the nucleus. Now these protons and neutrons are collectively known as what? As nucleons. So if you are being asked what is the nucleon number of so and so element or atom, you're able to what? To bring it out. Now if we have known these little points, and you should put at the back of your mind again that the scientist that discovered electron is who? Is J.J. Thomson. He did an experiment which is known as the what? The cathode ray experiment, actually. Now come to look at it. Now what to look at? These electrons are found in an atom, but they are found in orbitals. Where are they arranged? That is where electronic configuration now comes into being. Now there is a way that they are arranged in an atom or even an orbital. Now there are 4 quantum numbers that you need to look at, that you need to pay attention to. Now this video you can get to watch it time and time again in case you miss any point at all. Now there are 4 quantum numbers. We have what called the what? The principal quantum number. The principal quantum number. Number 2, we have what called the what? The subsidiary quantum number, also known as the what? The azimuthal quantum number or angular momentum. Angular momentum. Now, then we have number 3, the magnetic quantum number. Magnetic quantum number. Then of course number 4, we have the what? The spin. Now these are the 4 quantum numbers that determines electronic configuration of an element or an atom, so to say. That is to say, in layman's language, these numbers will help us to know how to arrange electrons in an atom. I'm going to go through them now. Remember, just little point. I don't want the video to be too long because we still have questions to tidy. Now this principal quantum number, what does it do? First off, it determines the shell, main shell. Let me just go through it. I'm talking about main shell. I'm talking about the K, L, M, N, O. Now, for instance, this is the nucleus. The first shell is the K shell, while the next shell is the L shell. The other one is the what? M shell. And of course, just like that, the other one is the N shell. Now, in this situation, N is equals to 1 for the K shell, N is equals to 2 for the L shell, N is equals to 3 for the what? For the M shell. Now, these are main shells. And what number determines it is the principal quantum number. Of course, what you see that I've done here, they represent them with N. It's represented with N, but that is for atomic chemistry. But you should know that N can also be used to represent a number of moles. Of course, talking about calculation in chemistry and stoichiometry. We're going to jump into that, but let's continue. But this subsidiary quantum number, but please, the principal quantum number also determines size, also determines the energy, what? Energy level. So you have to put the point at the back of your mind. Then this subsidiary quantum number, what does it determine? Now, remember, sir, that if you are doing configuration using the KLMNO to know the number of electrons that this can carry is gotten by what? 2n squared. For instance, for K, n is equals to 1. Therefore, if the maximum number of electrons that K can carry will not be what? 2, 1 square. 1 square means 1 times 1. 1 times 1 is 1 times 2. That will give me what? That will give me 2. So K can carry a maximum of what? Of 2. But this, I want to solve for this. N is equals to 2 for the L. That means it will not be what? 2 bracket what? 2 square. 2 square means 2 times 2. That is 4 times 2. That is what? 8. Now, that is how to know the number of electrons that the main shell can carry. But this subsidiary quantum number, what does it determine? What does it determine? It determines the subshells. or what they call the orbitals. The S, we're talking about the S, the P, the D, the F. Now, these are regarded as what? As subshells, while these ones are regarded as what? As main shells. Now, the maximum number of electrons that this can carry is determined by the orbitals that are found inside. So a shell actually contains one or more what? Orbitals. Now, look at it very quickly. I swear to, but they look the information small, small. Now, this S has one what? Orbital. P has 3. D has 5. F has 7 orbital. Quickly, we're not going to waste time. This S that has one orbital now, because an orbital carries a maximum of 2 electrons, it simply means that S can carry 2 electrons. P can carry how many electrons? 6 electrons. D can carry 10 electrons. F is what? 14 electrons. But remember, it's for your level. But if we move further, we have SPDF. We also have the G. But I think we should center on this first based on our exam focus, which is UTME and what? And Ssce. Now, we have known already subshells, main shells, models of atoms, scientists that describe different models of atoms, subsidiary quantum numbers, principal quantum numbers, and the rest. But let me bring this out, that this angular momentum or subsidiary quantum number, remember with L, that L is equals to what? N minus what? Minus 1. Now, this is how to get L. Remember, L determines subshell, or you can simply say breaks down shell to what? To orbitals. Now, if we have made mention of that, there are some questions that I want us to target from this little point that we have shared now. We don't look at now. So, not fail to look at this video and of course share with your friends where they write Ssce, we want to write UTME by 2025 UTME, 2026 rather, UTME. Be very careful. These are killer points that you must know. And do well also. There are many points and questions that you can see in my book. The book is called The Effective Compendium in Chemistry. It's also in what? In biology. Of course, if you want a copy, you can send a DM, of course. Make a comment on the video. Of course, I can get it across to you wherever you are in Nigeria. Now, let's go. Now, if we have looked at all these, remember we are focusing on electron right now. There are some things that we need to bring out quickly. There are some questions I want us to check. Now, look at this particular question. This question is from the effective compendium. But before we begin to look at that, now, if I want to do the configuration of an element, for instance, using SPDF, talking about carbon, for instance, carbon is 6 using the SPDF notation. Now, the little shortcut that I want to follow is that there is the energy level to follow. For instance, we have 1x, 2x, 2p, 3x, 3p, 4x, 3d. Now, you can use this energy level to determine the electronic configuration of the first 30 elements. You get it now? Now, if I want to do the configuration for carbon now, it will not be, because carbon is having 6. The atomic number here is 6. That means the number of proton is 6. But remember, because it's a neutral element or atom, the number of electron is also 6. So indirectly, the proton number is determining or determines the number of what? Electron only for a what? A neutral element. Now, if we come here now, we can say that what? To arrange this electron here, which is 6, 1x, because x can carry a maximum of 2. 1x2, go to the next one, remaining 4. I cannot put 4 here. Go to the next energy level. So I'm using the word energy level to refer to what? Shell or orbitals. Now, will not be what? 2x2. So remaining 2 here will not be what? 2p2. Now, this is the configuration for what? For carbon. I can likewise do for other elements. For instance, I want to do for that of what? Oxygen now. 1x2, 2. Oxygen is 8. So now be 1x2, 2 P what? 4. Now, this is the configuration for what? For oxygen. But there are some questions I want to bring out from the effective compendium, so you know a practical exam question from what we have said. So let's jump into the questions quickly. All right, now you can see a basic question here from the effective compendium. Of course, I wrote the numbers in chapter 1 of the effective compendium because it's chapter 1 of that book. I actually looked at the atomic aspect of chemistry, looking at molecules, looking at ions, looking at configurations, periodic table, separation techniques. Of course, these are basic areas in chemistry that you must know first before you begin to jump. Now, we have a question here, more tidy and sharp. They said, how many electrons are in the L shell of phosphorus? Now, look at phosphorus. The subscript represents the atomic number, and atomic number is number of protons. While these represent the atomic mass, which is number of protons and what neutrons. Now they're asking us a easy question. Easy question. Remember what we said just now. We said that the first shell, of course, because the number of protons is 15 and it's a neutral element, that means the number of electrons is also what? 15. Now, the first shell is the K shell and it takes 2 electrons. Now, the next shell, which we solved just now, ought to take 8 electrons. So if I remove 2 from here, that means I'm left with what? 13. That means I'm going to arrange what? I'm going to arrange what outside now? I'm going to arrange 8. So it becomes what? 1, 2, 3, 4, 5, 6, 7, 8. Now that is 10. Now remaining 5. So the next shell is going to take 5. 1, 2, 3, 4, 5. Now remember, this is the K shell. The first shell is the K shell. The second shell is the L shell, while the other one is the what? M shell. So the number of electrons that the L shell can carry is how many now? Is 8. So the answer actually to this question is what? 8. So L shell contains what? 8 electrons. Now let's look at this other one. This other one is quite dicey, but it's still simple still. But remember the rule that we said just now, that S has 1 orbital, P has 3 orbitals, D has 5 orbitals, F has what? 7 orbitals. That if I want to do the configuration here, remember that S has 1 orbital. Now look at the orbital block configuration. This is 2 electrons. The electrons should be arranged in opposite direction. Now this law, this rule is what is called the what? The Pauli exclusion principle. Now this Pauli exclusion principle, what does it state? It said if I want to arrange electrons now in the layman's way, in an orbital, the electrons should be arranged in opposite what? Directions or spins. Now look at this particular one now, that if I decided to arrange this one in opposite direction, we are using 1 orbital, but when it gets to this P has 3 orbitals. So if I want to arrange it, definitely I'll bring out the 3 orbitals. Now look at it now. But because this P is a degenerate orbital, please put this at the back of your mind. These orbitals here are said to be what? Degenerate orbitals. Why are they degenerate orbitals? The reason being that they contain more than 1 orbitals. So X has 1, so it's not degenerate. Degeneration means multiplicity. Now make we look at this P has 3, D get 5, F has what? 7. So this law I want to apply here is what is called the word, the Ohm's rule of orbital multiplicity. Quickly now, this 5 here, if you want to arrange in any degenerate orbital at all, if you are filling electrons in a degenerate orbital, the first thing to do is to do what? Is to partially fill the orbitals. So we have 3 orbitals here. I'll partially fill it. 1, 2, 3. Remaining 2. Then of course I'll pair. Then of course, so it's now 4. Then of course this one is what? 5. That means how many unpaired electrons are in this element is actually what? 1. So this element is having 1 unpaired electron. Now, because it's having 1 unpaired electrons, any element at all, when you do like this and you can see that it has 1 or more unpaired electrons, those elements are said to be what? To be paramagnetic what? Elements. But if you decide to do the configuration and you do not come across any unpaired electron, just know that that element is said to be what? Is said to be diamagnetic what? Element. So we have what? Paramagnetic, and we have what? Diamagnetic element. If it doesn't have unpaired, it's diamagnetic. But if you do have paired, if you do have unpaired, that means it's para. Like this one is para. But if it doesn't have, that means it's diamagnetic. So these are questions I'll be revealing. But remember, this is the basic aspect of chemistry that I'll be tackling for those persons that are writing the 2026 UTME examination. But remember, early preparation is always what? Key. It's not just for those persons that are preparing for UTME or SSC exam. Basically, if you want to really know chemistry, you must know these points at the back of your mind. So really, the other videos I'm going to upload, but do yourself a favor, do well to what? Subscribe. So each time I drop a video, you get to what? Catch it. So Mosjaro is out of here. I'll see you in my other videos. Please do well to share to your friends that are preparing for the examination. And of course, you can make contact with me, and of course, you can leave a comment in the comment section. See you in my next video.